Good. Okay, so my name is Claudia Dragoste. I come from a public water company from Spain, close to Barcelona. And I'm here to explain how we can have advanced hydraulic models using open source software. Yeah, so let's start. Here we are. So this is my company. And before getting into the technical stuff, I would like also to explain, well, for a hand, I will not read all of this data, but just to have an idea about the complexity of our network. It's about water supply network and also wastewater network. So the water company from Manresa is the name of the city, serves water to 17 municipalities. As you see here, it's like 17 municipalities, but finally we give water to 150,000 people, more or less. So the size, it's not so big, but we have a quite very complex network, so it's very beautiful to work with it. Second, this last 2 years, Spain got money from Next Generation, and in this program that was for the water companies, in the first call between 158 projects, there were 30 projects that received money, and we finished on the 9th position. The beauty of our project is that the theme is that everything we will develop will be open source software and hardware with no license. So open source software, open hardware. So I'm really very grateful to our CEO, it's Antoni Ventura, because he believes in this idea, because more than one time I heard I don't understand this idea that we pay and then we share with everybody. So I'm really thankful to our CEO. In this project, there are four main cores. There will be development in the telecontrol SCADA area, GIS, the sensors, that is a very important part in this project, and applications. I'm the project manager in the GIS for the GIS part. In fact, I was working before in another company, in another water company from Girona. I really invite you, if you can, to come, because there is a very nice event in Girona talking about open source software in GIS. And I joined the team because of the project, because of the beauty of this project. And my idea of how to focus or to use this money is not to develop customized applications for us, then we can share it with other companies. I was thinking, why don't we contribute to what already exists and try to work with the standards applications or concepts and be part of this beautiful community that works and develop open source software. So first piece of in my part of work is Giswater. Giswater, we used it for a long time. Is somebody here that doesn't know what Giswater is? Everybody knows. Everybody hears. Okay. So Giswater is, in fact, it was launched in 2014. So as you can see, it's like a solid software. It was developed maintenance of the water supply and wastewater networks. But from the very first beginning, when he was developed, it was developed to be connected with US EPA, I mean Epanet and SWMM. It's software that it's completely in the FOSS4G database, so all the intelligence, all the functions are developed there. And then they developed the Giswater plugin. That is a QGIS plugin, so you can connect the database with the QGIS through this plugin that also connects with the Epanet and SWMM. I don't have time to enter into all the details. The main functionality is, of course, that it's to keep the inventory of the network, to edit the data, visits and events. Map zones is a concept, a very beautiful concept that map zones like hydraulic sectors, district matter areas. I mean the map zone that you want to control or the consume. So when you have different maps, different district matter areas, it's easier for you to control the efficiency. Then there is the pressure zone. Another interesting map zone. So they are dynamically generated. So this is the beauty, that you define the node and the two arc that is the head of the map zone, and then with the process of flood into the network, they are created. So and the borders are the closed valves or the valves or valves basically that that have one direction. On this moment, it's taken in account to just the valve direction, the valves that are one direction. No, so these are the borders of the map zones, or the head of another map zone. So an application, application, it is calculated the map zone, the district matter area, and in the same time it's calculated taking account all the heads of the zone that allow to enter the water, and then the heads of the zones that are connected. So it calculates dynamically what are the quantity of the water that was that is put in this map zone. So it's something that it's calculated, and I didn't see other programs that do this. And then the mean cut. The mean cut is when there is a leak. We find a leak in a pipe, and you have to fix it, which is the area that you have to isolate for the other network. And then this is for the water. For the wastewater, it's flow trace or flow trace. It's when you. These are also very nice features. When you put you are in one node, and you want to see which is the water that is collected on that point for hand. This is very helpful for the last point of the wastewater network that are in it goes out in the nature. Medium, or the plant, the wastewater plant, or if you are interested in to see one point where it goes. Planification of the network, alternatives and budgeting that I will talk later, and hydraulic models, and let's enter into the hydraulic models. So, Epanet and SWMM are very powerful tools for modeling, but they have like the big limitations, that there is no GIS interface and no connections to the database. And in case of the SWM, it's not possible to do a dual model 1D, 2D. And we have solutions for everything. So the advantages of working with Epanet or SWM together with Giswater and Iber, and I will explain later what it is. Iber, it's like this presentation that I'm trying to do, I would have need 10 presentations, and I really want to share all this knowledge, man. Maybe you need it, and it's like you can use it, because everything is published. I say it like from now. Everything is published, and everything can be used. So, Giswater, as I said that before, from the very first beginning, even when it didn't exist, the Giswater plugin, they were created Giswater with the idea to interconnect with Epanet and SWM. So Giswater gives this interface and functionalities with Epanet and SWM. And then Iber is a Spanish project. There are the universities from Barcelona and Coruña and somebody else. There are like their links. The last slide, I put all these links to take our picture. What Iber does is two-dimensional hydraulic model for the simulation of the surface. And what they are doing now, I think that very soon they will publish, well, a part, it's done already, which is they connected Iber with SWM in such a way that we can have now, we can do the hydraulic models for the wastewater that is 1D, 2D hydraulic models. And what they are working on, and they will publish it soon, will be the, in fact, they will do it like a plugin for QGIS. Because now you can use this algorithm, but it's like an academic way, so you have to prepare it like in a very uncomfortable way. But they are working, and very soon they will be published, the plugin. So you will have the interface. And for another hand, Giswater also make it easier for the Giswater project. Okay, so I would like to talk. Can you tell me with how much do I have? 15 minutes. Yeah, it's fine. So I will try to talk about the things that I consider that are very important in Giswater, and the strength of working with Epanet and SWM in combination with Giswater. First of all, what I would like to explain is that in the database of the Giswater, there are, it's in such a way designed that they were taken in account what Epanet and SWM needs. So, for instance, and we will start with the first strength, in Giswater, there is this duality of the same information. From the criteria of the inventory, what is orange? It's the inventory world, and what is blue? It's the hydraulic world. So in inventory world, for a node, I don't know if you can. It's impossible to read. I will give you an example. In the inventory world, we draw a valve as a node. We will not start to draw all the valves as arcs. But in for Epanet, a valve it's an arc. or a flow meter, we draw it as a node. But in EPA, it's also an arc. From the pumps, the same. Then, it's difficult to be seen here, Giswater came with a concept that is named inlet. So inlet, it's a node that, depending of the sectors that you bring in the same time to simulate in Epanet, can be reservoir or a tank. I mean, inlet, it's in fact it's a tank, but that connects two sectors. So if you want to simulate the sector by itself with the start point, the tank, this tank will be a reservoir. If you simulate it with the other sector that it's connected with, this node is considered tank. So in Giswater, as I explained, that you already defined in Giswater for every element of the network how it behaves in the inventory world, in the GIS, let's say in the GIS world, and how it's supposed to behave in the Epanet world. So what's beautiful here is that, for instance, I modeled once using a software, very expensive, but I had to bring all the data in that software, and then there I had to set up the features in the, how they have to be, and it's a long process, and it's difficult to have the hydraulic model to achieve to calibrate it. But then I promise you that how to keep it updated is even more difficult. So it's solved here. I mean, everything is stored in the same database that is a GIS database. They have the information for GIS and for hydraulic model. So here is, I put it for the wastewater network. Something also very beautiful. For instance, you can declare for a pipe that is in the hydraulic side, can be a conduit, but also can be a pump. An arc can be a pump that impulses the water, or a weir, or an orifice, or an outlet. But sometimes we don't, in wastewater, we don't draw like pumps, or what I saw that, for instance, inside of this chamber, there is, it's like, finally, it's like a pump station, I think, or I don't know how they name it. Inside there is a pump, and then there is like a pipe that, or there is kind of construction inside that the function is to be weir, no? But we don't in the GIS side, we don't draw all these details. We just draw one point that is the pumping station. What Giswater has are like a non-visual element that you can add to the node that it's pumping station, and they name these elements flow regulators. And you defined them there, and then, maybe later, I will jump. So, when you declare all these things in the Giswater environment, there is one moment that you decide to send the data to Epanet or SWMM. And on right this moment, when the file point ENP is prepared, inside inside the functions of the Giswater, it happens like an explosion. They name it like flying transformation. So where in water the valve is a node, it's a node, in the INP will become an arc. So I can do how many models I want every 5 minutes, because all the information, I have it in the database of the GIS, or in the main database. So going back, because I wanted to explain you something else. Yeah, I have time. So I was talking about the sectors that are generated dynamically, and you can see nothing here. Here is the capture of the table that where you define what a sector is, saying the name, that is the head of the zone, the two arc, and you even can say, besides the valves that are closed, which other node you want to consider it like a stopper, or if you maybe want to consider something like it's closed, but to ignore it. So it gives you this this option. So this is one part of how you customize how you customize your models. Then we go for the second one. Second one is a field that exists in Giswater, that is EPA type. So EPA type is depending of the EPA type that you choose. You then have to inform different parameters, and these attributes that you have to inform are according to the parameters that Epanet or SWM are Epanet or SWM needs. Besides the EPA types that Epanet or SWM needs, you also can say undefined. And these will be the elements that will not bring to the EPA type, to the Epanet or SWM. Then there is some other nice way to choose what is brought or not, what is brought or not in EPA type, that it's state type. For instance, I have a state that it's operative, that it's our network, and I say, okay, but I'm drawing something that is provisional, and I don't want to bring this to Epanet. So setting this like a subtype, those pipes don't go to the EPA side. Another nice thing that we can use, they have, like, besides the fields with the real data, they use the customized, so you have fields where you can inform the customized value. Why are useful? Because you don't want to lose the real data. For instance, for calibration, you realize that, okay, I know that this tank is on this zeta, altimetry quota. But for my calibration, I need to change it. But I don't want to lose the real one. So for this, it's very good to use the customized. Then exist the DS scenarios. It's the dynamic scenarios. Here you can play with your models, because here you can put for all the attributes of the network, like values that you want to try the model without modifying the values that are in your production network. Very useful. I mean, you can have your many dynamic scenarios related to many models, and still people consulting the data will see the real data. Then there are these the name per sector, it's planified area, where you can delete and add without modifying the production network, and you can bring this planifying red to model model it. So also inside the Giswater, you can declare the demand patterns, pumps, control of the elements, and so on. All the options that Epanet or SWMM needs, there are in Giswater. Here is the main, is how you create the INP, send it to Epanet, and you even, after you calibrated the model and now there are no problems, in just one step you generate the INP, execute it in Epanet or SWMM, and bring back the data. With this work that we will have, I will jump the questions. You can find me here. It's very important. This also during this work that we do now, as we have a very brilliant engineer in hydraulic, we will be add many algorithms, hydraulic algorithms in the Giswater. So Giswater will have these algorithms. Then, because QGIS Desktop, it's not very user-friendly for a normal user, we decided to use the QGIS web client. Tomorrow will be the presentation of QGIS web client, so I really insist you to go to see how QGIS web client works. It's with a very clean code and very customized. And talking about the customization, this afternoon one of the developers from BGO, that is the main developer of Giswater, will be here giving, it's this afternoon around 4 o'clock, giving a presentation about how you can personalize what it says, is this one, that how you can create like QGIS plugins and that are compatible with the web client, with the QGIS web client too. And then another nice idea was in one of presentations of SourcePol that were the developers of the web client too. They appeared with the idea to use the standard SensorThings API. So we want to use this also to incorporate it in the Giswater in order to have the online data of the sensors, it's a very interesting concept. So interesting that thank you, Tudor. He let me know these days that in the version 336 they added as a new data provider this SensorThings API. So this is the future. And adding this SensorThings API server, including it in this project, we can see the real-time data. So finally, this is like this modern concept, like digital twin. We have it. I mean, we have it, and with open source software. And yes, yeah, that's the idea. So here are basically the links. So everything is published. And I even put the links for the most complicated part for me was to understand the SensorThings part. So here are the links, and I put also the link of the public endpoints that give you a lot of information of what this powerful. I see it like a very powerful tool, or not tool, but concept to use it for our data, for our sensor data or IoT database that I think we already need it. Thank you.